Thank you all. Welcome to this very interesting session on intelligent manufacturing. I'm very happy to have two of our largest partners, Rockwell and Microsoft, in this, and I will let them do 99% of the talking. I will stay relatively quiet. What I'm going to do is have you introduce yourselves, Nitya and Diego, and we'll go from there. In the meantime, I will bring up the presentation.
Thank you, Vinay. I'm Diego Tamburini. I'm a principal category manager for team, joining you from Seattle, Washington.
Hey, thanks, Diego. This is Nitya Kumar Parameswaran. Hello, everybody. I'm from Rockwell, and I manage the enterprise analytics product portfolio for Rockwell. So I have a team of product managers and product marketing focusing on the analytical products for the manufacturing industry. Nice to meet you guys.
Okay, with that, I want to throw up this quick slide, which shows how our joint solution works together. And we'll come back to this, but I just wanted to set the context in which we are talking about in an industrial, in an open and intelligent industrial edge. So I want to, this is sort of just a slide that visualizes the solutions that we're going to be discussing.
Yeah. Hi. So I just want to start with what is there in the minds of the manufacturers today, right? So if you look at the manufacturers, they're looking at how do I improve my asset utilization? Like, I have my assets. Am I getting the maximum out of my assets? Looking at a line as a whole or a process as a whole, like, am I performing at the right optimized level? Are there any room for improvement where I can optimize my operations, right? So this is what is always in the minds of the manufacturers. And if you look at, when I want to do this analysis, like, how do all my plants across the globe, like, are they all performing at the same level? Like, can I see how they are performing, and can I learn best practices from one plant and adopt in the other? That's the second thing, right? Like, I want to see visibility. I want to see how my plants are performing, how assets are being utilized across my different locations. The third thing is, like, some of these assets, like, we'll come to this slides later, but some of these assets have been there for like 15 years and 20 years, maybe ending their life cycle. Can I get more out of this? How can I extend some of these assets' life? Because it's a big capital expenditure, but can I extend it by another 2-3 years? Like, what can I do to do it? And lastly, like, it is like, how flexible is my system? Like, can I switch between making one product and another product? Like, for example, we have seen, like, with this COVID times, like, a lot of manufacturers are kind of switching their lines to do like something that was just one of their product lines, but that's what is being produced a lot now, right? So that flexible system allows them to kind of shift and pivot based on market needs. Next slide. If you look at, like, what is the current market scenario, like, what's the current market condition? Now, what we have found is, like, the industrial process manufacturers are completely ready to make this transformation, like, to trying to answer those questions. They're in the 5 to 8% category. The reason why is, again, because, like, some of them are struggling. Hey, where do I start? I have these assets that are 20 years old. There are some assets that are 10 years old. Now, where do I need to begin? The second thing is, like, it's also the human capital constraints in terms of, like, I need to go through a cultural change. Like, when I bring in IT and OT together, there is a big cultural change here. Now, who takes accountable for what? Because these two organizations have been working kind of in a siloed fashion. We need to bring them together. And if you look at them, like, most of them are in the pilot phase. The reason being, like, you have all these great technologies, like, to provide, say, to do analytics. I have machine learning models and libraries available. AI is the next big thing. and I have other like extended reality and augmented reality. So there are a lot of these technologies, and customers are looking at how do I prioritize? Like, how do I bring these things together? Because that's where the complexity comes. Like, I need to understand what these technologies bring in and what is the use case that I have to solve it. So the good thing here is like at least 80 to 85% of the manufacturing is kind of in the pilot stage, and now we want to just take them to the next stage. So Vinay, if you move to the next slide. So where the challenge here is the industrial analytics is slightly different from the day-to-day what we see as consumer analytics, right? So there's a high volume of data that comes in from these assets. Because these machines, some of these machines run 24/7, and I am having this constant time series data coming out of these assets. So I need to process these information. The second thing is like these systems have come into production at different points in time, right? Some are 20-year-old equipment, some are like 5-year-old equipment. So data coming from these disparate systems are not always structured. So again, now you need to integrate these data from these different systems to make a meaningful insight and then leverage the technologies to do some advanced analytics. Now, there are some use cases that requires almost a near real-time action. So I need to process not only high volume of data, but the rapid data that's coming out from these different systems, correlate this, like aggregate it, and then I should be able to even take actions quickly. Now, the other one is like, how do we leverage my domain expertise, right? I have deep process and expertise within my plant, but now I have these IT technologies. Now, how do I bridge that gap? Like leveraging my domain expertise at the same time, how do I use these technologies and get some real outcomes? So next slide, Vinay. So where we are looking at here is like, when you look at like analytics, like in the industrial space, it goes from anywhere from descriptive analytics to diagnostics to predictive to prescriptive. Like it can be as simple as like, hey, I just need to know, is my asset working? Is it running? Is my line running, right? And I want to look at like, is it performing at its best? Now, if a fault happens, like why is it happening? Is it because of a one asset in a big line, or is it something, the product that is not being configured correctly in my line? So I need to look at like more in terms of why something is happening. Then getting into like predictive and prescriptive, like where can I predict if I know like my output is going to go down? Can I foresee that? And before there's a major disruption comes in my production line, can I predict that and then take some precautionary action so that I don't have a major failure? And then comes like, how do I avoid it? Right? One is like kind of forecasting a fault. The next is like, how do I avoid it in the future? I don't want some of these, I would say, downtime to happen, because that influences my output. So if you look at analytics, right? So it's kind of like you have the descriptive one, the diagnostics, the predictive, the prescriptive. Necessarily, it's not in sequence. Like it's not to be seen like I need to start in descriptive, then move to diagnostics. It just all depends on the use case. It depends on the user persona. So there are certain use cases which are more descriptive in nature, certain use cases that are more predictive in nature. So the key thing here is like, I'm not only using this technology, I also need to understand, hey, what is my use case? And who am I ultimately benefiting? Is it the operators, or is it the enterprise or CIO who's looking at improving the efficiency, or my process managers? Because that's all very key in order to understand, hey, where these analytics come in. So we go to the next slide, Vinay. So I have like where, hey, when I look at an industrial analytics platform, so I always need to think about, am I serving the process engineers? Are my applications serving the data scientists? Because each have their own unique problems that they face, and they need some of these technologies to kind of address those problems. Like if you take a data scientist, I want to do more advanced analytics. I want to look at data from different sources, bring it together, and see how I can improve some at a very strategic level and take some initiatives. I also might get some customer issues coming in once my product reaches the shelf. Now, how do I quickly resolve those customer issues? Right? Whereas if you look at the use case that's faced by process engineers, they are a little bit more different. Like, how do I optimize my process? Now, can I predict downtime and or a machine failure, and can I take some corrective actions even before the disruption happens? At the same time, when you provide these applications to these end users, now or capabilities. Now you need to look at, hey, am I going to, is it cloud? Is it on-prem? Is it edge? Right? Again, these are some of the factors that kind of influences. If you look at, depending on the end user and the use case, maybe certain applications need to be at the edge because I need some immediate action. I need some near real-time action to be taken. And I have a high amount of data coming out for this particular use case, and it may not be really, I'd say I cannot be that quick to take do the analysis in the cloud and bring it back to the edge and do the connection, right? So edge can be one way. There can be other use cases where cloud makes more sense. So if you look at the criteria, like for deployment, like how immediate I want to take some actions, like what is my connectivity to these assets or these systems? Now, what's the volume of data that's coming in? How secure I need to keep this data? So all these kind of influences where I need to surface my application. Again, there is no one solution that fits everything. It all, again, depends on the use cases. And we also see like manufacturers, they're not looking at one use case, right? They come with a multiple set of use cases, which provides value. So every use case has a different treatment. Next slide, Vinay. So the way we approach, like Rockwell approaches this, like we have a full stack approach, right? And the common thread is, again, it is the data, it is the information. So I want to make sure like that information that we get from the assets are preserved and it is available for different applications and analytics to actually leverage that. So if you look at our portfolio, right? So we have like applications like augmented modeler and data flow ML, which are more like data scientist oriented. And then you have products that can actually run at the edge. We also like partnered with PTC, like where we use their IoT platform like ThingWorks Analytics to actually provide some of these insights. And Euphoria, where we also want to integrate with the extended reality and augmented reality to provide a much more real-time experience to the end user. So we're bringing all these different technologies together, but at the same time, we want to make it really easy for the end user to consume, right? So if you look at some of the products, I'm going to maybe give an example of a couple of products, like how we make it easy for the end customer, leveraging these technologies. Then I'll hand it over to Diego from Microsoft to talk about some of the IoT technologies that Microsoft provides. Vinay, next slide. So in my initial one, like when I had the descriptive analytics, diagnostic analytics, so one of the key things which we wanted to see, like how if I don't have visibility to my assets, now I don't want to spend a lot of my precious dollars trying to have a big, let's say, investment to try to get that. Is there some way I can quickly get that piece of information? How can I very quickly provide that insight in terms of, is my device running fine? Am I getting any faults? If I'm getting any faults, can I surface it immediately? Can I alert it? And again, is there any action that I can take immediately based on the nature of the fault that occurs? Now, how quickly can I get to that, right, if I'm just collecting information? So there are products like FDA Analytics for devices where it already has profiles already built into the application or the appliance. And when you connect it to the network, it can identify these assets that fits the profile and surface like a lot of parameters in terms of, okay, what is the status of the asset? Like, what is the output of the asset? Am I seeing any fault occurring? If the fault occurs, I can see the fault code and surface that up and also take actions. So we don't want to spend a lot of time in terms of implementing this, but if I have a prepackaged capability where it's much easier to deploy and I see immediate value and I'm starting collecting data as quickly as possible, then I can start focusing on more on like advanced analytics, right? Now that I have the information, that I already know like how my assets are performing. So then I want to move to the next stage. So if we go to the next product, next slide, sorry, Vinay. Here I want to talk about like another product, like Logix AI. So this is a machine learning module that sits right next to the controller. Now, there's two ways to do analytics and machine learning. One is giving all the use cases to the data scientists and the data and let them look at the different libraries and techniques that they have, and then they can apply the right one. But there are certain use cases where we can pre-package it, give it directly to the end user, who are the process or the control engineers. So here is one example of a product where we prepackaged set of models. And this particular product is for a couple of use cases. I'll get into the use case in a bit, like soft sensors or anomaly detection, where I don't want to, again, have a big practice and take a lot of time. I want to be focused on more on time to value. Give this particular application to the process engineer who understands the process, who understands the asset, and they can actually train the model, and they can look at like how the model is performing, and am I getting the right anomaly that I'm expecting, and then say, hey, when they are happy with it, then they can actually deploy that particular model into their production scenario. But here, the controls engineers don't need to know about the data science behind it. They don't need to know the data science skills or the libraries being used, because already prepackaged for a specific use case. So for example, like here, next slide, Vinay. Like I'm taking an example of, like, say, a chemical industry, and if everybody's like very familiar with, like, there's a lot of hot and harsh conditions there, and there are a lot of sensors in these operating in these hot and harsh conditions. As simple as, like, I might have a temperature sensor near a furnace, and that temperature is used to drive some of the input parameters into the furnace. But given the hot and harsh condition, the sensors can give erroneous readings. Now, if you take that reading, which is not the right reading, to actually influence some of your input variables, that's going to affect the quality. So here, like, one of the examples that we found is like using Logix AI to train the module, so that given the set of input variables, I can predict what would be the temperature. So it's a kind of a soft sensor use case. So yes, I do measure the temperature, but I can also derive the temperature based on other variables. So now I have an actual reading from the sensor, and I also have a predicted or a modeled value based on the inputs. Now I can compare and see if there's any spike, right, which is abnormal. I know it's a sensor problem. It's not a furnace issue. So I don't. In this case, what I would do is, like, I wouldn't take the input from the sensor. Instead, I would take the input from the model itself, because that's a much more a better representation of what's really happening in the furnace rather than the sensor reading. So just an example of how you can kind of simplify some of these libraries, some of these techniques, and give it directly to the end user. Like another example, next slide, Vinay. So another use case here, again, in a food and bev industry. So some of these products are produced at a very high speed, and of course, there's sometimes you have quality issues. But these quality issues are comes to the manufacturer after the product hits the shelf, or after it lands in the hands of the consumer. Now, when these complaints come in, like, I need to go back and look at, okay, what was my production parameters when that particular batch or lot was produced? Now, when I want to do this analysis with my data scientists, like, I need to have all the data for the data scientist to perform that action. Now, what happens is, like, because of this high-speed nature and data being collected at different points in time, a lot of times you spend a lot more time kind of preparing the data before you actually do the root cause analysis. So some of the products that what we are looking at, like, how do I automate some of this IT/OT integration, right? Like, if I can timestamp the data at the source itself and link it to, let's say, even my batch or the lot, then it makes it much easier for my data scientists to perform these root cause analysis when some of these quality issues happen. So what we are looking at is, like, hey, leveraging the technologies that we have. At the same time, how do we package it in such a way that it's sometimes I can direct it to the process engineers or the control engineers. At the same time, how do I bridge some of the complexities of the IT/OT integration, and how can I automate that? So that's kind of like some of the Rockwell products are kind of focused on. Next slide, Vinay. So our approach is like, hey, we have 100 years of experience in this domain, and we are committed to kind of documenting and sharing these best practices with our customers, where we want the customers to focus on the business, but we can bring in the domain expertise. But again, like, your industry first and some innovations, like automating this IT/OT integration, leveraging like AR and VR visualization capabilities in order to further improve the production process. And some solution templates, like for some known problems, we already have some pre-built configured capabilities where the customers have more flexibility in terms of configuring the application, but these are for like known use cases. And again, we are not doing this alone, right? We are leveraging our partner ecosystem, like Microsoft and Cisco and PDC, who are best in class in their domain and leveraging their technologies and having pre-built capabilities for our solutions. And again, like we are consulting practice, because that's the key thing, right, in terms of adoption of these technologies in the analytics spaces. Like, how do I leverage my domain expertise? How do we leverage the learnings from similar use cases? So again, we have a consulting practice and implementation services that helps kind of take the customer through this journey. Last slide before I hand it over to Diego is just to think about the key thing here is like, how do I simplify the data science practice? Like that's kind of how customers should also think about, like it should not be that complex. And how do I drive actions? Like what kind of actions can I drive real time? Not every use case requires a real time action, but need to clearly identify what are those, what falls in the real time bucket versus what falls in more the strategic kind of bucket. And again, extending the flexibility at an enterprise scale, not just a plant level or a line or an asset level. How do I extend that more at enterprise scale to kind of unlock the potential of the analytics technologies that are available? At this point, I'll take a pause and hand it over to Diego.
Thank you,
talk more
good day, everyone,
from their IoT
joining us today.
Diego?
Like I mentioned earlier, my name is Diego Tamburini. I'm a principal category manager for manufacturing in the Azure team. Joining you from Seattle, Washington. In my part of today's presentation, I'd like to share Microsoft's point of view of manufacturing and our partner-first approach for going to market in the industry, exemplified, of course, by the fact that I'm here presenting with two of our great partners. And could you go on mute, please? Two of our great partners, Rockwell and ZEDEDA in this event, and our view of how manufacturers can respond to the current COVID-19 crisis. So I'll go to the next slide, please. So when we look at the forces that are driving transformation in the manufacturing industry, we see a common trend, and that trend is about digitizing operations and use the data generated by machines, devices, to extract insights to improve these operations and differentiate products and services, just like Nitya has been describing so far. So, for example, you see that by 2030, 65% of manufacturers will save 10% of OPEX through process digital twins using IoT and ML and machine learning. By 2024, 40% will leverage IoT data to reduce unplanned downtime by an estimate of 25%. And by the end of 2021, half will invest in supply chain resiliency and AI for productivity improvements of 15%. So obviously, these are forecasts, these are estimates, but kind of give you a flavor of the potential improvements that are driving digital transformation in manufacturing. So these numbers make the whole digital transformation talk much more tangible and concrete. Here we see real technologies apply in real industry scenarios, producing real improvements. Next slide, please. So at Microsoft, we articulate our point of view, or our industry narrative, if you will, of what the priorities in the industry are by defining these 5 priority scenarios that you see on the screen. Transform your workforce, engage customers in new ways, create more resilient supply chains, build more agile factories, and unlock innovation and deliver new services. Next slide, please. So if we go into a little bit more detail on each of these scenarios, we can see that the first one, transform your workforce, is all about connecting your workforce with the information and training. They need to do their jobs, augmenting them with AI and machine learning to make better and more informed decisions. The second scenario, engage your customers in new ways, is about delivering new and differentiating customer experiences across marketing, sales, and service. The third one, create more resilient supply chains that can absorb disruptions and shocks like the current COVID-19 crisis. I'll be saying a few words about in a minute. The fourth scenario, build more agile factories. This is where the whole 4.0 and smart factories come to play. How to use IoT and machine learning to optimize operations and improve quality. Again, like Nitia was describing in his portion. And finally, unlock innovation and deliver new services. It's about designing connected, more sustainable products and attached services that shift the mindset from one of shipping products in a transactional manner, which is a sell and forget model, to one where manufacturers deliver product as a service, where the relationship with the customer continues after the sale. Next slide, please. So, of course, I will be remiss if I talk about the industry and I don't acknowledge the current situation with the COVID-19 pandemic and its impact in the industry. In a sense, COVID-19 has heightened the need to implement digital transformation initiatives that were already in flight and effectively, in many cases, accelerating their implementation. So in particular, helping address the skills gap, and we've been hearing about the skills gap for several years already, but now as factories are being repurposed to manufacture personal protective equipment, this is a particularly poignant effect. Do everything remotely. Now, because people can, it's difficult to go to the factories, people want to monitor equipment, optimize production parameters, provide expert consulting, all remotely. Provide safe work environments. Until now, safety, when it came to safety in factories, it was primarily about injuries, preventing injuries. But now we are talking about tracing and tracking and of people potentially infected with the virus, leverage automation to help with social distances requirement, etc. And last but not least, plan and optimize supply chains, assess and address risk, make them more resilient and to quickly adapt to disruptions. Next slide. So to address these market forces and the additional impact of the COVID virus, we are now focused, Microsoft, through partners, we are focused on 3 priorities with our customers. One is navigate the now, which basically supporting our customers' most pressing needs to maintain business continuity despite the disruptions and the restrictions of the moment. We are still going through this phase, unfortunately, for the most part. The second is plan the comeback, help our customers prepare to rebound their business in a time of continued uncertainty. And lastly, when we are hopefully getting out of the crisis, shape the new normal, reimagine our customers' businesses and to leverage insights, streamline operations, and basically be ready for the next disruption. So to that end, we have organized our industry priority scenarios for manufacturing to align with these 3 priorities. Next slide, please. So if we go back to the industry priority slide that I showed a few seconds ago, next slide, and overlay the impact of COVID-19, we can see the use cases that enable the response to the crisis. For example, under transform your workforce, we're talking about distributed team collaboration, remote working, remote remote maintenance and things like that. In more resilient supply chains, the one in the middle is about risk modeling and assessment and autonomous supply chain execution and how to respond to shocks in the supply chain. And more agile factories is about refactoring for the new supply and demand situation that the virus has caused, secure remote operating of factories, etc. So this slide overlays kind of the new urgency of the COVID impact, and our partnership with Rockwell and ZEDEDA align very closely to our fourth scenario. Obviously, it touches all of them, but more closely to the build more agile factories, which is all about using IoT data to optimize operations. Next slide, please. So those are the industry scenarios we consider priority. And although we have at Microsoft deep industry experience in manufacturing, we are not a manufacturing software company per se. We are a cloud platform company. And although our cloud platform has services and capabilities that are particularly important to manufacturing, namely IoT, AI, machine learning, HPC, advanced analytics, etc., the building blocks for the development of manufacturing solutions, if you will, it is mainly through software partners like Rockwell and ZEDEDA that we address the industry-specific scenarios and use cases. So we go to market in manufacturing with our software partners. We've always had and we intend to continue to do so. Next slide, please. So this commitment to partnering comes from the top of our company, as you can see from this quote from our CEO, Satya Nadella. We believe that partnering with software vendors that develop industry-specific solutions is a win-win-win, a win for the customers, a win for the partners, and ultimately a win for Microsoft. Next slide, please. So zooming into each of the industry scenarios I showed a couple of slides ago, we get this slide. And in here, you can see the use cases under each priority scenario. So as you can see, the use cases, the smaller boxes, are highlighted in yellow, blue, and green. So that indicates where in the COVID-19 response journey, react, recover, or reimagine, they are more relevant. So this slide is effectively a roadmap of the use cases and therefore the software solutions that we are prioritizing when it comes to partnering and going to market with software vendors. So if we zoom, next slide, if we zoom on the one that is particularly relevant for this talk today, build more agile factory scenario, you can see the use cases that we identify in there. Quality management, autonomous systems and robotics, enterprise asset management, etc. And also, so I picked this one because it's probably the one to which the Rockwell ZEDEDA solution you heard about from Nitya aligns most closely. And also because the implementation of the use cases here rely pretty heavily on the IoT and data analytics of our cloud platform, as Nitya described when he was explaining the solution architecture. So let me describe basically the same, but this time from the perspective of us, the platform provider. So next slide. So when we talk about developing IoT solutions, generally speaking, we talk about solutions that connect to devices on-premise in your factory floor, perhaps do some processing on-premise, then connect to the cloud to send some data, also known as data ingestion to the cloud, store this data, perform some analytics, display the results, and perhaps even execute some actions in response. So this is in essence what any IoT solution does. of course, various degrees of sophistication. So going to my last slide, if we zoom, next slide, please. If we zoom into these blocks, we see that Azure provides the cloud services, the building blocks that I was referring to earlier, that developers at software providers like Rockwell and ZEDEDA string together to build their solution. So for example, they can use the Azure IoT Edge to do some processing on the edge, the Azure IoT Hub to ingest IoT data into the cloud, the Azure Device Provisioning Service to manage the provisioning of software to the devices, Azure Data Lake or Azure SQL Database to store this data, and then Azure Stream Analytics to analyze it, and then Power BI to visualize it. So basically an end-to-end data flow of IoT data. So in conclusion, before I hand the presentation back to Vinay, we consider ourselves as a platform company that provides the building blocks for our software partners, companies to develop industry solutions for their customers. But we're not just that, we're intimately immersed in the industry so we can understand what our partners and our customers need so we can deliver, hopefully what's the best cloud platform for manufacturing that is out there. So with that, I hand it back to Vinay. Thank you very much for your attention.
Thank you so much, Nitya. Thank you so much, Diego. As you know, we are approaching time here. I wanted to talk about, a few sentences about where we are in terms of the ZEDEDA Azure integration, as well as what we're doing with that with Microsoft. So if you really sort of look at it, where we have partnered up, and these are our two closest partners in terms of what we're doing in the industrial space. One is around how we are doing the integration with Azure, and the other is how we take legacy applications that our Rockwell already has, years and years of developed applications, and are able to bring both those worlds together. And this is how we do it, right? So the integration that we have done with Azure is a deep integration, right? Where we are running on Rockwell hardware with our virtualization layer, but being able to work completely integrated with Azure and the Azure edge stack that they have developed, and being able to bring applications that already exist in Azure from companies like Rockwell and their partner PTC, as well as bring on applications like what Nitya was talking about, applications like Edge Gateway, like FDA for devices, right? All on the same compute platform. This is the integration that we are doing with Microsoft as well as with Rockwell. Just kind of, changes how we are able to bring to life the two things that our biggest partners have described. And I would, with that, I would let Diego and Nitya, if you have any last words, I'll give you the floor. Otherwise, we can close it down.
Sure. Thanks, Vinay. And hey, from Rockwell's perspective, we are excited. We are excited to work with Microsoft and ZEDEDA in bringing some of the together in a much more integrated fashion. Right. So this is a journey that we have started, and we are in this together to see some success in this area. Diego, anything from your side?
Yeah, from my end, I reiterate the fact that we are only successful through our partners, and we've been, obviously, Rockwell and ZEDEDA, we've been working with them for some time already very closely, and we pride ourselves of having a solid platform, but it's only through the subject matter expertise and their insight that they get from customers that we can deliver good solutions through partners like you guys. Thank you.
Thank you, guys, and I really appreciate your time and your effort into putting this panel together. It was really informative. Thank you all, and hope to see you soon.